Hello, welcome to Hawk Math. Today we are going to be attempting the 2000 AIME 2 problem number 7. In this problem, it states, given that this equation, find the greatest integer that is less than n divided by 100. Now, when we look at this equation, we should start by looking for patterns because we see a whole bunch of factorials on the denominator. So, what do we notice about it? Well, if you look, this 2 and the 17, they add up to 19. The 3 and the 16, they add up to 19. So this 2, 3, 4, 5, that keeps increasing, while the 17, 16, 15, 14, 13 keeps decreasing. And we see that they all add up to 19 on every single term, including this one over here. Well, what does this remind us of? Well, to me, I immediately think of combinations. If we had, for example, 19 combination 2, this would be 19 factorial over 2 factorial times 17 factorial. And if we had a 19 factorial in the numerator of all of these, they would simplify nicely into combinations. So let's see what happens if we multiply this whole equation by 19 factorial. We would get 19 combination 2 plus 19 combination 3 plus 19 combination 4 plus so on, and then up until 19 combination 9. Then over here, we would get 19 combination 1 times n. Okay, now we should need to solve this. Well, what's a fast way we can add up all of these? Well, we know that the sum of all the combinations of one row, so for example, the sum from n equals 0 to 19 of 19 choose n, that's going to equal 2 to the 19th. So, using this fact, we can then say that 19 combination 0 plus 19 combination 1 plus 19 combination 2 up until 19 combination 9 is going to equal 2 to the 19th divided by 2. Now, why is that? Well, we see that if we were to, because of the property with combinations, how 19 combination n is equal to 19 combination 19 minus n, this is the same thing as 19 choose 19. This is the same thing as 19 choose 18. This is 19 choose 17. So if we were to reflect that and add this to itself, we'd get the sum of all of those equals to 2 to the 19th times 2, 2 to the 19th over 2 times 2, which just gives us that. So now, after we know this, we can just subtract 19 choose 0 from both sides, and 19 choose 1 from both sides. Sorry, that should be 1. And then we would get that the sum that we were looking for, this 9 and this term, that 19 choose 2 plus 19 choose 3, all the way up until 19 choose 9, is equal to this. So we know that 19 combination 1 times n is equal to 2 to the 19th over 2, which is the same thing as 2 to the 18th, minus 19 combination 0, which is 1, minus 19 combination 1, which is 19. So 19n equals 2 to the 18th minus 20. So n equals 2 to the 18th minus 20 over 19. Now, going back to the problem, it asks us to find the greatest integer that's less than n over 100. So we need to now figure out what n is. So in order to compute this quickly, I know that 2 to the 9th equals 512. So 2 to the 18th is 512 squared. So 512 times 512. So this is 4, 2, 1,000, 0, 5, 1, 2, 0, 0. 5 times 2 is 10, 6, and 25. So now we're adding that up. And we get 4, 4, 1, 2, 1, 6, 2. So that is 2 to the 18th power. Now we need to subtract 20 and divide by 19. So when we subtract 20, that's going to give us 2, 4. And now all we do is divide that by 19. So I'm just going to, for more room, I'm going to just remove that up here and just do long division straight off of this. So we have a 1, subtract that, 7, 2. That's going to go in 3 times. So 30 and 27 is 57. And then subtract that, and we're going to get 15. And then bring down a 1. I think that's going to be 7 times. And now we can actually stop there, because we know this number is going to have 2 more digits. And so we know it's 1, 3, 7, and then 2 more digits. Now, the question asks, find the greatest integer that's less than n divided by 100. Well, n divided by 100 is going to be 137 point something something. So the greatest integer, less than that, we don't even need to finish the long division, is just going to be 137. So there we go, we have our answer, and we're done. So this problem wasn't too bad. We just need to realize that this could be rewritten as combinations, and then using the summation formula, we could rewrite the whole expression and solve for n. So I really hope you enjoyed this problem. Thank you for watching. If you want to see more like this, please like and subscribe to the channel.